Hello, welcome to our next Tuva Science Connections, where we're going to be exploring uncertainty in ice caps, where we're helping our students work with the performance expectation of HSESS 2-2, where our students are looking to analyze geoscience data to make a claim that one change on the Earth's surface can create feedbacks that cause changes to the other Earth systems. So in order for us to get to the point where we can comfortably make a claim that a change to one leads to a change in the other, which is what our students are working on here, what they're applying, the skills they're applying here, it necessitates us having an understanding of the mechanisms that would connect those two things and/or the ability to look at multiple lines of evidence and connect it through logical reasoning steps of how a change in one place logically would relate and be related to a change in another place. So, for example, if our students have been looking at the atmospheric carbon dioxide, maybe the data sets out of Mauna Loa over the last many decades, and if they've been looking at changes in air temperature globally throughout our planet over the last many decades, and maybe they've also been looking at greenhouse gases in our atmosphere and how that relates to, there's greenhouse gases in our atmosphere as well as the emissions of greenhouse gases here on the Earth's surface. So we've got multiple pieces of evidence that are already bouncing around in their heads, and they've seen that all of those things are increasing over time. It presents an opportunity for our students to look at another line of evidence, and maybe one of those, maybe where there's been an impact, or maybe there's sort of a difference or a decrease that's going on over that same time period. And then to think through those logical reasoning steps or what those mechanistic steps would be as they're building out that claim. So we can use a data set or the activity of patterns of change in ice caps, a data set about water masses and our different ice sheets to answer questions like, how did the Antarctic and the Greenland ice sheets change from 2002 to 2017, a similar time frame than they've looked at for other data sets? Or how did the degree of uncertainty in the measurements change over time in Antarctica and Greenland, as that uncertainty piece is always a critical piece of science. So what we can do is we can work with this data set within Tuva to get at this with our students, and let's orient to what's going on in this data set. First, who collected these data? So these data were collected by NASA. They were collected by the GRACE mission, which is this great acronym for the Gravity Recovery and Climate Experiment, in which there were satellites that were orbiting our Earth, and they were taking measurements of how much water were there. This is helpful context to understand what we are looking at. Other helpful pieces of information is that this was launched in 2002, and the mission ended in 2017. And it was looking to measure monthly the amount of water storage in these two regions, in Antarctica and Greenland, hence our questions about Antarctica and Greenland. So there's 326 cases. A case is a monthly value that were recorded, and there are 4 attributes. So let's take a look at what those attributes are. What information do we have from this GRACE project? Well, we have the region, we have the year. Here it's recorded as decimal year, which is an interesting conversation to have with your students. We've got the water mass from these gravitational measurements that the satellite was taking. And then we have our uncertainty with the phenomenal units of gigatons. It's sort of hard to think about gigatons of uncertainty, but I'm getting ahead of myself. First question, let's look at how the amount of water mass, or the amount in both of these ice sheets, changed over time. So we want to look at time, and we're interested in this water mass difference. And this is relative to 2002. So this isn't, what it is. We're not looking at an absolute value of how much water mass there is. We're taking a baseline from 2002 when the GRACE project started, and we're comparing against that. Okay, so interesting. There's some things going on in the data, but we're interested in the regions of let's see what's going on. And this is a data set that has changed over time. Oh, that's not what I meant to do. Okay, we need the regions in here. So let's add the regions. Oh, okay, that's looking much better. So now we can get a sense of, so our red dots, our red line here is from the Antarctic region, and our green line here is from the Greenland ice sheet? Well, looking at the data, we can see that the ice sheet, or the amount of water mass in each of these ice sheets, has decreased over that time scale. So that's interesting. What about that uncertainty question? And so we can plot our uncertainty and see what's happening. Oh, wow. There's some like interesting things going on here where the uncertainty was higher and then decreased, and then it stabled out for a while around 2003, and then it stabled out for a while until late 2016, 2017, and then it increased again. And so it's interesting as we can work on our pattern recognition here to think about why that might be the case. Why might we be seeing this pattern? We can also think about using these data or our data from looking at our water mass, so we can bounce back and forth, and we could make a projection forward, and we could think about, okay, well, where might the water mass be in 2030 if we were to sort of play this out and keep moving this axis out, and then we could maybe add a line to think about, what would our guess be? Okay, so if we're going to, oh, that always happens to me. If we're going to sort of project out, what's our expectation of where this might be? Oh, I need to make my axis even longer, right? But we can play and we can tinker and we can use these features to help us answer these questions and dive into this data set further to help us think about kind of what's happening in the polar ice caps across the same time period. So our questions like, how did the ice sheets change? Well, they both decreased. They had less water mass at the end of the data set that in comparison to what they had in 2002. The degree of uncertainty, right? That was that really interesting graph. And then we can engage in that interesting conversation of why that graph might be that way. And then we can also kind of take that a step further and use this as an opportunity to just think more broadly about uncertainty and how that relates to science and conclusions we make from our data. So this is just one of many data sets within Tuva that can help us with our Earth and space science performance expectations, as well as our topic areas relating to the subject area. If you haven't already, I encourage you to take a look through the rest of the content library to find something else that might work for different units, or even as part of this, another line of evidence to include within this. So with that, I hope you have a great day and enjoy playing with your data. Thanks so much.